Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about the properties and formulae of a few 3D shapes like the cube, cuboid, cylinder, cone, sphere, hemisphere, and prism. Mensuration is an important and scoring topic of the quantitative aptitude section in competitive exams like GRE, GMAT, SSC, RBI exams, railway exams, and so on. There are different formulae to solve questions on this topic. So, knowing and applying these formulae is very important to do well in this section. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's now understand a few properties of the 3D shape cube. A cube is a solid three-dimensional figure. All the faces of the cube are shaped as a square. Hence, the length, breadth, and height are the same. Two faces meet each other along a common line called the edge. Three edges meet a common point called the vertex. A cube has 12 edges, 6 faces, and 8 vertices. Each face of the cube meets 4 other faces. Each vertex of the cube meets 3 faces and 3 edges. Now let's understand these properties uh, with the help of this diagram of a cube. Now as you can see in this diagram, this cube is a three-dimensional figure and it has 6 square faces, and 2 faces meet along a common line, and this common line is called the edge. Now as you can see, there are 12 edges in a cube. Now 3 edges meet at a common point called the vertex. As you can see here, this edge, and this edge meet at a common point called the vertex. And as you can see in this figure, there are 8 vertices. Now each face of the cube meets 4 other faces. Supposing you consider this face of the cube, then you can see that it meets 4 other faces: this face, the side face, and the back face. Now faces meet each other at right angles. As you can see here, this face and this face meet each other at right angles. The opposite faces in a cube are parallel to each other. So this top face and the bottom face are the opposite faces, and as you can see, they are parallel to each other. The opposite edges in a cube are parallel to each other. Now if you look at this figure, you will see that this edge and this edge are opposite edges, and as you can see clearly they are parallel to each other. Similarly, this edge is parallel to this edge. Also, this edge is parallel to this edge, and so on. So the opposite edges in a cube are parallel to each other. A cube has 12 face diagonals and 4 body diagonals. Now, if you consider this face of the cube, then this face has 2 diagonals. So each face of a cube has 2 diagonals. Since there are 6 faces, a cube has 6 multiplied by 2, that is 12 face diagonals. And as you can see in this diagram, there are 4 body diagonals. One from this vertex to this vertex, one body diagonal from this vertex to this vertex, one body diagonal from this vertex to this vertex, and the fourth body diagonal from this vertex to this vertex. So a cube has 12 face diagonals and 4 body diagonals. Let's now learn a few formulae for cubes. Now we know that the length, breadth and height of a cube are all equal since each of the faces of a cube is a square. So let length be equal to breadth be equal to height be equal to A. Then the volume of a cube is equal to the length multiplied by breadth multiplied by height, which is nothing but A multiplied by A multiplied by A, which is A cubed. So volume of a cube is equal to A cubed. Total surface area of a cube is equal to 6A squared. Now you know that there are 6 faces in a cube and each of these face is a square. Now if you consider this square face of a cube, then the area of this square face of the cube would be equal to A squared since each of these sides is equal to A. Now since there are 6 faces in a cube, the total surface area of the cube would be equal to 6 multiplied by A squared. Lateral surface area is equal to 4A squared. Now look at this cube. This is the top surface and this is the bottom surface. Now excluding those two surfaces, there will be 4 lateral surfaces. The remaining 4 surfaces are known as the lateral surfaces. Now since each of the lateral surface is a square, the area of each of the lateral surface would be equal to A squared. And since there are 4 lateral surfaces, the lateral surface area would be equal to 4 multiplied by A squared. So total surface area of the cube is 6A squared because there are 6 faces in a cube. And lateral surface area is equal to 4A squared because there are 4 lateral surfaces. Length of a face diagonal of a cube is equal to root 2 multiplied by A. Now consider this square face of the cube. Here this side is A, this side is A, and this is the face diagonal of this particular face of the cube. Now if you join this side and the face diagonal, you will get a right angle triangle with the hypotenuse being the face diagonal. Now since this is a right angle triangle, applying the Pythagoras theorem, you will get the length of the face diagonal of the cube as root 2 multiplied by A. Length of body diagonal of a cube is equal to root 3 multiplied by A. Now if you consider this side of the cube, which is A, this is the face diagonal. This is the body diagonal. Now if you join this side, the face diagonal and the body diagonal, you get a right angled triangle with the hypotenuse being the body diagonal. Now this side is A and we know that face diagonal is equal to root 2 multiplied by A. Now applying Pythagoras theorem to this right angle triangle, we get the length of the body diagonal of the cube as root 3 multiplied by A. Perimeter is equal to 12A. Now perimeter is nothing but the length of all the edges of the cube. Now since each edge is equal to A in a cube and since there are 12 edges in a cube, the perimeter of a cube would be equal to 12 multiplied by A. Remember these 6 formulae to solve problems on cubes. Let's now learn a few properties about the 3D shape cuboid. A cuboid has 6 faces, 8 vertices and 12 edges. All the angles formed at the vertices of a cuboid are right angles. All the faces are rectangular in shape. Any two opposite faces are parallel and congruent to each other. Two diagonals can be drawn on each face of the cuboid. The opposite edges are parallel to each other. A cuboid has 3 dimensions: length, width and height. A cuboid has 12 face diagonals and 4 body diagonals. Now let's understand all these properties with the help of this diagram of a cuboid. Now as you can see, in this cuboid has 6 faces: top, bottom, front, back and 2 sides. And it also has 8 vertices. As you can see, there are 12 edges in this cuboid. Now all the angles formed at the vertex of a cuboid are right angles. Also, as you can see, all the faces are rectangular in shape. And any two opposite faces are parallel and congruent to each other. That is, the top face is parallel and congruent to the bottom face. The two uh, faces on the sides are parallel. Similarly, the front and the back faces are parallel and congruent to each other. Also, the opposite edges are parallel to each other. As you can see here, this edge is parallel to this edge and clearly they are parallel to each other. Similarly, this edge is opposite to this edge and they are parallel to each other and so on. Now, a cuboid has 3 dimensions: length, breadth and height. Now, two diagonals can be drawn on each face of a cuboid. Supposing you consider this face of the cuboid, clearly you can see that you can draw two diagonals on this face of the cuboid. And since there are 6 faces in a cuboid, there will be 12 face diagonals. And clearly from this diagram you can see that there are 4 body diagonals. Let's now learn a few formulae regarding cuboid. Volume of a cuboid is equal to its length multiplied by breadth multiplied by height, which is nothing but L multiplied by B multiplied by H. Total surface area of a cuboid is nothing but area of the 6 rectangular faces. Now as you can see in this cuboid, the area of the top and the bottom faces would be L multiplied by B and L multiplied by B. The area of the two side faces would be B multiplied by H and B multiplied by H. The area of the front and back faces would be L multiplied by H and L multiplied by H. So area of the 6 rectangular faces would be equal to 2 multiplied by L multiplied by B plus B multiplied by H plus H multiplied by L. This is the total surface area of the cuboid. Lateral surface area. Lateral surface area of a cuboid is nothing but the area of all the faces of the cuboid excepting the top face and the bottom face. So when you add the surface area of the two side faces, the front face and the back face, you will get the lateral surface area as 2H multiplied by L plus B. Length of face diagonal of a cuboid. Now let's consider the bottom face of this cuboid. The bottom face would be E, F, G and H. In this, let's consider the triangle FGH. Clearly you can see that it is right angled at the vertex G. Now here you can see that GH is equal to L and GF is equal to B. Since the triangle FGH is right angled at G, FH would be the diagonal. And applying Pythagoras theorem, we get the value of the diagonal FH as square root of L squared plus B squared. Now this diagonal FH is nothing but the face diagonal of the cuboid. So the length of face diagonal of the cuboid would be equal to square root of L squared plus B squared. Length of body diagonal of a cuboid. Consider the triangle BHF. Here clearly you can see that this triangle is right angled at F. So BH would be the diagonal of this right angle triangle BHF. Now we know that BF is equal to H and HF is the face diagonal of the cuboid, and we know that it is equal to square root of L squared plus B squared. Now applying Pythagoras theorem, we can get the value of BH as square root of L squared plus B squared plus H squared. Now BH is nothing but the body diagonal of the cuboid. So the length of the body diagonal of the cuboid would be equal to square root of L squared plus B squared plus H squared. Perimeter. Perimeter is nothing but the boundary of the cuboid. So if you add all the edges of the cuboid, you'll get the perimeter, and which would be equal to 4 multiplied by L plus B plus H. So perimeter of a cuboid is equal to 4 multiplied by L plus B plus H. Remember all these formulae which will make solving problems on cuboid easy and fast. Let's now learn a few properties of the cylinder. A cylinder is a solid object with two identical flat ends or bases that are circular or elliptical and one curved side. A cylinder with circular bases is called a circular cylinder. A cylinder with elliptical base is called an elliptical cylinder. The height h is the perpendicular distance between the bases. The radius r of a cylinder is the radius of a base. Axis is a line joining the center of each base. Now let's understand all these properties with the help of this diagram of the cylinder. Now as you can see here, the cylinder has two identical flat ends, this one, and one curved surface. Now these flat ends are called the bases, and these bases can be either circular or elliptical. If the base is circular, then it's called a circular cylinder. If the base is elliptical, then the cylinder is called the elliptical cylinder. Now this is the center of this base, and this is the center of this base. Now the line joining the center of each base is known as the axis. Now the perpendicular distance between the two bases would be this line joining the two centers of the bases. So this is the height of the this is the perpendicular distance between the bases, and this is nothing but the height of the cylinder. Now if this is the center of the uh, base, then this would be the radius of the base. This radius of the base is nothing but the radius of the cylinder. So radius of the base is also the radius of the cylinder. Let's now learn about the types of cylinders. There are three types of cylinders: a right cylinder, an oblique cylinder, and a hollow cylinder. A right cylinder is one whose two bases are exactly over each other and the axis is at right angles to the base. This is a right cylinder, and as you can see here, the two bases are exactly over each other and the axis is at right angles to the base. An oblique cylinder is one whose one base is displaced sideways and the axis is not at right angles to the base. This is an oblique cylinder, and as you can see here, this base is displaced sidewise and clearly the axis is not at right angles to the base. A hollow cylinder is one that is hollow from the inside out and has a difference between its internal and external radii. The hollow cylinder's base resembles a region enclosed by two concentric circles. This is a hollow cylinder. Now, here the hollow cylinder is hollow from the inside. Now, as you can see here, this is the external radius and this is the internal radius. And clearly there is a difference between the external radius and the internal radius. Now the hollow cylinder's base resembles a region enclosed by two concentric circles. Let's now learn about a few formulae of cylinders. Consider a cylinder of radius r and height h. Volume of a cylinder is equal to pi r squared h. Now, volume of a cylinder is nothing but area of the circular base multiplied by height. Now, we know that area of a circle is pi r squared and height is nothing but the height of the cylinder, which is h. So, volume of the cylinder would be equal to pi r squared h. Curved surface area of the cylinder is equal to 2 pi r h. Now this is the curved surface of the cylinder. When this curved surface of the cylinder is unfolded, we get a rectangle whose length is equal to the circumference of the circular base. Now we know that circumference of the circle is equal to 2 pi r. Also the width of the rectangle is nothing but the height of the cylinder. We know that the height of the cylinder is h. So the area of the rectangle is length multiplied by width, which is nothing but 2 pi r multiplied by h, that is 2 pi r h. Now this rectangle is nothing but the curved surface of the cylinder. So the curved surface area of the cylinder would also be equal to 2 pi r h. Total surface area of a cylinder is equal to 2 pi r multiplied by h plus r. Now total surface area is nothing but curved surface area plus area of the two uh, circular bases. Now we know that area of the curved surface is 2 pi r h and area of the two circles would be pi r squared plus pi r squared, which is nothing but 2 pi r squared. So total surface area of the cylinder would be equal to 2 pi r h plus 2 pi r squared. If you take out 2 pi r as the common, then you will get total surface area is equal to 2 pi r multiplied by h plus r. So total surface area of the cylinder is equal to 2 pi r multiplied by h plus r. Remember these three formulae to solve problems on cylinders. Let's now learn a few properties about cones. A cone is a shape that has a curved surface and a circular base. A cone has one face only, which is the circular base of the cone. A cone has no edges. A cone has a circular base whose center joins its vertex, showing the axis of the respective cone. The slant height of the cone is the length of the side of the cone taken from the vertex to the outer line of the circular base. It is denoted by L. The altitude of a right cone is the perpendicular line from the vertex to the center of the base. It coincides with the axis of the cone and is represented by H. Now let's understand all these properties of the cone with the help of this diagram of a cone. Now as you can see here, this cone has a curved surface and a circular base. Now this circular base is the only face of the cone. There are no edges in a cone. Now this is the center of the circular base. If a line is drawn from the vertex to this center of the circular base, this line would be the axis of this cone. Now the length of the side of the cone from the vertex to the outer line of the circular base would be the slant height, denoted by L. So this would be the slant height L from the vertex to the outer line of the circular base. Now this is a right cone. If a line is drawn if a perpendicular line is drawn from the vertex to the center of the circular base, then this length of the perpendicular line would be the um, altitude of the right cone. Now in a right cone, the altitude coincides with the axis of the cone. Altitude of the cone is represented by h. So slant height is the length of the side from the vertex to the outer line of the circular base. The height of the right cone is the perpendicular line from the vertex to the center of the base. Let's now learn about the types of cones. There are two types of cones, right circular cone and oblique cone. Right circular cone. The cone whose axis is perpendicular to the base is known as the right circular cone. Here, the height of the cone is the same as the length of the axis of the cone. The apex of the cone lies just straight above the center of the base. Now, this is a right circular cone. As you can see here, the line drawn from the apex of the cone to the center of the uh, circular base is the axis. Now as you can see here, this axis is perpendicular to the base. So this is a right circular cone. Now here, the line drawn from the apex of the cone to the center of the circular base is also the height. So clearly here in a right circular cone, the height of the cone is the same as the length of the axis of the cone. Also, you can see here that the apex of the cone lies straight above the center of the base. Oblique cone. A cone whose axis is not perpendicular to the base of the cone is known as an oblique cone. Here, the apex is not just straight above the center of the base. Also, the height of the axis length Also, the height and the axis length is not the same in this type of cone. Now, this is an oblique cone. As you can see here, this is the axis, that is the line drawn from the apex of the cone to the to the center of the circular base. This is the axis of the cone, and clearly you can see that this axis is not perpendicular to the base. Also, you can see that the apex is not straight above the center of the base. Now here you can see that this is the height of the cone. Clearly here the height of the cone and the axis length is not the same in an oblique cone. Let's now learn a few formulae of cones. Consider a cone of radius r, height h and slant height L. Volume of a cone is equal to 1 by 3 multiplied by pi r squared h. Curved surface area of a cone is equal to pi rl. Now look at this cone. You can see that this is the curved part of the cone. Now the area of this curved part of the cone is the curved surface area of the cone. It's also known as the lateral surface area. And curved surface area is equal to pi r L. Total surface area of a cone. Total surface area of a cone is the sum of the area of the circular base and the area of the curved part of the cone. Now we know that the area of the circular base is pi r squared. Area of the curved part of the cone is pi rl. So total surface area is equal to pi r squared plus pi rl. If you take out pi r as common, you get total surface area is equal to pi r multiplied by r plus L. Remember these three formulae to solve problems on cones. Let's now learn about spheres. A sphere is a perfectly symmetrical three-dimensional circular shaped object. As you can see, this is the diagram of a sphere. Let's now learn a few important elements of a sphere like radius, diameter, circumference, volume, and surface area. So what is a radius? The distance between the surface and the center of the sphere is called its radius. So look at the sphere here. This is the center of the sphere. Now the distance between the surface and the center of the sphere is called the radius of the sphere. Diameter. The distance from one point to another point on the surface of the sphere passing through the center is called its diameter. Now in this diagram, this is one point on the surface of the sphere and this is another point on the surface of the sphere. So this distance from one point of the sphere to the other point on the surface of the sphere passing through the center of the sphere is called the diameter. So the diameter passes through the center of the sphere and connects one point on the surface of the sphere to another point on the surface of the sphere. Circumference. The length of the great circle of the sphere is called its circumference. Great circle is a circle that cuts the sphere exactly in half. Now look at this diagram of a sphere. Now this is the great circle, and as you can see, this great circle cuts the sphere into two equal halves. Now the length of this great circle is the circumference of the sphere. Volume. The amount of space occupied by any spherical object is called its volume. Surface area. The region occupied by the surface of the sphere is called its surface area. Let's now learn about a few properties of the sphere. A sphere is perfectly symmetrical. There is a single surface which is rounded. Know the difference between a surface and a face. A surface is rounded whereas face is flat. So a sphere has a single surface which is rounded. A sphere has no edges or vertices. A sphere is not a polyhedron because it does not have vertices, edges and flat faces. A polyhedron is an object that should definitely have a flat face. All the points on the surface are equidistant from the center. The curvature of the surface remains the same along the entire surface. Let's now learn about a few formula of spheres. For a sphere of radius r, the volume of a sphere is equal to 4/3 pi r cubed. Total surface area of a sphere is equal to 4 pi r squared. Diameter of a sphere is equal to 2r. Circumference of a sphere is equal to 2 pi r. Remember these four formulae to solve problems on spheres. Let's now learn about a few properties of a hemisphere. So what is a hemisphere? A hemisphere is a 3D geometric shape that is half of a sphere with one side flat and the other side as a circular bowl. It is formed when a sphere is cut at the exact center along its diameter, leaving behind two equal hemispheres. The flat side of the hemisphere is known as the base or the face of the hemisphere. So look at this diagram. This is the diagram of a sphere. So if this sphere is cut at the exact center along its diameter, we get two equal hemispheres. So these are the two equal hemispheres. Now as you can see here, each hemisphere consists of one side which is flat and the other side which is in the shape of a circular bowl. This flat side of the hemisphere is known as the base or the face of the hemisphere. Let's now look at the properties of a hemisphere. A hemisphere has one curved surface and one flat circular base. So as you can see in this hemisphere, you can see that this is the curved surface and this is the flat circular base of the hemisphere. Now just like a sphere, a hemisphere has no edges or vertices. A line segment that connects two opposite points on the circumference of the circular base of a hemisphere and passes through its center is said to be the diameter of the hemisphere. So look at this hemisphere. This is the circular base of the hemisphere. This is the center of the circular base. If you consider these 2 points as the opposite points on the circumference of the circular base, then the line passing through the center of the circular base and connecting these two opposite points on the circumference is the diameter of the hemisphere. So this line is the diameter of the hemisphere. A line segment from the center of the circular base to any point on its curved surface is the radius of the hemisphere. So in this hemisphere, if this is the center of the circular base and this is any point on the curved surface, then the line segment that joins the center of the circular base to any point on the curved surface is the radius of the hemisphere. So this is the radius of the hemisphere. Let's now look at a few formulae of hemisphere. Consider a hemisphere of radius r. Let's now look at the formula for the volume of a hemisphere. Now the volume of a hemisphere is half the volume of a sphere. Now we know that a volume of a sphere is 4 by 3 pi r cubed. So volume of a hemisphere would be half of 4 by 3 pi r cubed, which is nothing but 2 by 3 pi r cubed. So volume of a hemisphere is 2 by 3 pi r cubed. Let's now look at the formula for the curved surface area of the hemisphere. Now the curved surface area of a hemisphere is half that of the sphere. Now we know that the curved surface area of a sphere is equal to 4 pi r squared. So curved surface area of a hemisphere would be equal to half of 4 pi r squared, which is nothing but 2 pi r squared. So curved surface area of a hemisphere is equal to 2 pi r squared. Let's now look at the formula for base area of a hemisphere. Now the base area of a hemisphere is circular in shape. We know that the area of a circle is pi r squared. So base area of the hemisphere is also equal to pi r squared. Let's now look at the formula for the total surface area of a hemisphere. Now total surface area of a hemisphere is equal to its curved surface area plus its base area. Now we know that the curved surface area of a hemisphere is equal to 2 pi r squared and base area of a hemisphere is equal to pi r squared. So total surface area of a hemisphere would be equal to 2 pi r squared plus pi r squared, which is nothing but 3 pi r squared. So total surface area of a hemisphere is equal to 3 pi r squared. Remember these four formulae to solve problems on hemisphere. Let's learn about a few properties of a prism. So what's a prism? A prism is a solid figure with flat faces, two identical bases, and with the same cross section all along its length. The flat faces of a prism are called the lateral faces. Now look at this figure of a prism. As you can see, this prism has all flat faces. It has an upper flat face and a lower flat face. The upper flat face is known as the upper base and the lower flat face is known as the lower base. The flat faces of the prism are called the lateral faces. Now these are the vertices of the prism and these are the edges of the prism. Let's now learn about the different types of prisms. Now, prisms can be classified based on various criteria. Now, prisms can be classified on the type of polygon of the base. There are two types of prisms based on the type of polygon base it has. They are the regular prism and the irregular prism. If the base of the prism is in the shape of a regular polygon, the prism is a regular prism. This is the diagram of a regular prism. As you can see here, the base of the prism is a regular polygon. If the base of the prism is in the shape of an irregular polygon, the prism is an irregular prism. Now this is a diagram of an irregular prism. As you can see, its base is in the shape of an irregular polygon. So based on the type of polygon base a prism has, there are two types of prisms, regular prism and irregular prism. Let's now learn about the second type of prisms. Now prisms can also be classified based on the alignment of the identical bases. There are two different prisms based on the alignment of the bases, right prism and oblique prism. A right prism has two flat ends that are perfectly aligned with all the side faces in the shape of rectangles. Now this is a right prism. As you can see here, the right prism has two flat ends and all the side faces are in the shape of rectangles. Oblique prism. An oblique prism appears to be tilted and the two flat ends are not aligned and the side faces are parallelograms. So this is an oblique prism. As you can see, it appears to be tilted and the two flat ends are not one above the other, but it is slightly tilted to one side. The two flat ends are not aligned. And as you can see here, the side faces are parallelograms. So based on the alignment of the identical bases, prisms are of two types, right prism and oblique prism. Let's now look at the third type of prisms. Now prisms can also be classified based on the shape of the bases. The different types of prisms based on the shape of the bases are triangular prism where bases are triangle in shape, square prism where bases are square in shape, rectangular prism where the bases are rectangle in shape, pentagonal prisms where the bases are pentagon in shape, hexagonal prism where the bases are hexagon in shape, octagonal prism where the bases are octagon in shape, trapezoidal prism where the bases are trapezoid in shape. Now these are the diagrams of the different types of prisms based on the shape of the bases. Let's now look at a few formulae of prisms. Volume of a prism is equal to B multiplied by H, where B is the base area and H is the height of the prism. Note that only for triangular prisms, B is the base area, H is the height of the triangle and L is the height of the prism. So now we know volume of a prism is equal to base area multiplied by height. Now this base area depends on the shape of the base of the particular type of prism. For example, a triangular prism has a base which is in the shape of a triangle. So base area of a triangular prism would be the area of the triangle. So volume of the triangular prism would be equal to area of the triangle multiplied by height of the prism. Similarly, a square prism would have a base which is in the shape of a square. So base area would be the area of the square. So volume of a square prism is equal to area of the square multiplied by height of the prism. Similarly, a rectangular prism would have a base which is a rectangle. So base area would be the area of the rectangle. So volume of a rectangular prism would be equal to area of the rectangle multiplied by height of the prism, and so on. So this table gives us the different formulae for the different types of prisms. Let's now look at the formulae for surface area of prisms. Now there are two types of surface areas, the lateral surface area and the total surface area. Now lateral surface area of a prism is the sum of the areas of all its lateral faces, whereas the total surface area of the prism is the sum of the area of its bases and the area of its lateral faces. Now the formula for the lateral surface area of a prism is base perimeter multiplied by height. Now total surface area of a prism is equal to area of the two bases plus lateral surface area of the prism. We know that area of the two bases would be 2 multiplied by base area. Lateral surface area of the prism is base perimeter multiplied by height. So total surface area of a prism is equal to 2 multiplied by base area plus base perimeter multiplied by height. Remember all these formulae to solve problems on prisms. So now we know that total surface area of a prism is equal to 2 multiplied by base area plus base perimeter multiplied by height. Now remember that base area and base perimeter depends on the shape of the base of that particular type of prism. So this table gives the formulae for the total surface area of the different types of prisms. Viewers, please go through this video and understand the properties of the different 3D shapes. Memorize the formulae. Also, please do watch our video 3D shapes solved problems. If you have liked this video, please like, subscribe and share this video. Thank you.